So now let's focus on the other theorems, right? We have a semi-circle. I hope it's visible. Okay. So for a semicircle, we say that it's half. Let's say you have the center. So this is your diameter. And then it's going to subtend an angle here. This is A, B, and C. So a semicircle is half a cycle, half circle, right? Meaning that a semicircle, it cuts the circle in half and then subtends an angle. So sometimes they can give you something like this, can just go like this and be like this and this. So this is not a semicircle because it's not from the center of the circle, because center of the circle, let's say it's O. So this is not semicircle because it doesn't pass through the center of the circle. It's not a diameter, right? So how do you prove a semicircle? So a semicircle always subtends an angle of 90 degrees. So we're saying that A angle CB must be equal to 90 degrees. Reason is that it's an angle in a semicircle, right? So every time a semicircle, it subtends a 90-degree angle. And then now we need to check the other theorems, right? It's the circumference center theorem. Circumference center. Okay, so what is going to happen is that you will have an angle at the circumference and another angle at the center. So let's say you have something like this, right? So this is your center. Let's assume that this is your center. Oh, then this is A, B, and C. So what is going to happen if you are given that this is X, it means that the angle at your center is twice the angle at the circumference, so it's going to be 2x. So we're saying that angle O must be equal 2 times at angle A. Why? Because the angle at circumference is twice the angle at the center. Angle at the center is twice the angle at the circumference. I'm so sorry. So the angle at the center is twice the angle at the circumference. I'm so sorry about that. So we're saying that the angle here at the center, it's 2 times the angle at the circumference, right? So in another form, they can give you something like this. This is your center O, right? Sorry. Okay, this is your point. Okay, so here you are given that this is an X. So A, B, and C. So now they want angle O, right? Angle O1. So angle O1 must be equal to 2 times the angle CAB. Why? Because the angle at the center is 2 times the angle at the circumference. So in another form, they can give you something like this. This is the same reason that the angle at the center is twice the angle at the circumference, or the angle at the center is twice the inscribed angle. Sometimes it's called the inscribed angle. So let's say you have something like this, and this is going to be your center O. You have something like this, right? And this is your circle. So let's say you're given that this A, B, C, and O1. So in order okay, O1 and O2. So this angle here at B, let's say it's given to be X. And then they want angle O2. So angle O2 must be equals to 2 times A angle BC. Why? Because the angle at the center is twice the angle at the circumference. So there's some properties that you need to know in order for you to be able to answer some questions on Euclidean geometry. So let's say we are given, okay, so there's a theorem for this one, right? It's also another theorem, but we're not going to discuss it. We'll just go over it. See, this is O, A, B, C, B1, B2, this is D. So what we need to know is that the line that is drawn from the center of the circle to the midpoint of the chord, right? It bisects the chord, meaning that it cuts the chord into 2 equal halves. So we then say that angle B1 is 90 degrees and B2 is 90 degrees. So the theorem, it states that line drawn from the center of the circle to the midpoint of the chord is perpendicular to the chord at 90 degrees, meaning that it cuts the chord into 2 equal parts. So we also have okay, let's say we also have a radii. Okay, let me draw it separately. Another theorem. This is our center O. We have our chord AC. This is our B. This is our D. So we have a radii here. And this is 1. This is a 2. So what we need to know is that the angle at A, it's equal to the angle at C. Why? Because these are equal radii. These are radii. OA is equals to OC, which is a radii. So we say that O angle A, C must be equal to O angle CA, which is the same angles, right? What is the reason? Is that we say angles opposite equal sides, meaning that these angles is equal to this angle. Some other people previously were calling it that they're in the base of an isosceles triangle, but then we don't put the reason, so it's angle opposite equal sides. And then we say that it's because of that OA, it's equal to OC, so both are the radii, right? And then another thing that we need to know is the vertical opposite angle. Vertical opposite angles, right? So let's say we have something like this. So we need to know that this angle here is the same as this angle. So A is equals to A. And this angle here is equals to this angle here. Why? Because when you're standing here, you're able to view the person to your opposite. So hence we say they are vertical opposite angles. So these are some of the things that you need to know for you to answer the Euclidean geometry questions. And then we have parallel lines. So we say that parallel lines are fun, right? Parallel lines are fun. Oh, sorry. Yeah, parallel lines are fine. So for the F, we need to know that the angle here is the same as the angle here. So A, B, meaning that A must be equal to B. I hope it's still clear. What is our reason is that they are corresponding angles, right? Because the lines are parallel to each other. So again, when you have parallel lines like this, you need to know this is your A, this is your B. So these are called interior angles because they are inside, right? So we say that A plus B, this angle A plus angle B, sorry, these are angles. So angle A plus angle B must be equal to 180 degrees because co-interior angles, they add up to 180. So reason it's co-interior angles. So if we have another parallel lines like this, so we need to know that this angle here should be the same as this angle. So this is my A, this is my B. So A must be equal to B. Angle A must be equal to angle B because of alternating angles. I'm sorry for the spelling. So this is how it should be. And we should also remember that we have angles in a triangle. So when we sum them up, A, B, C, this sum up to 180 degrees because they are angles in a triangle. And we need to remember the exterior angle of a triangle. That exterior angle, let's say it's Z. The exterior angle of a triangle is equal to the sum of the interior opposite angles, right? So this is what you need to know, and then on our next session we'll be doing some questions.